we already have discussed. So far, let me go through the project things again in very brief. So these are the rubrics. You can find those things from the project specification. Your program must do these things, and the required task that you need to know, like required things or concept that you need to know is like if statement. You already have known those things. For loop or while loop. You use the defined function, main function, input validation. This is the important things. We already have learned input validation in last week, right? How we can validate the input? There are 3 ways. What are those 3 ways? First, use the try and except. Second, using the conditionals. Third, using loop, maybe while loop, so that until it is valid, you keep iterating. So for our case, how we can validate our input? Well, there are various things. One is like number of inputs. So in our case, our number of input is like 4, right? If we have less than 4 input, then we cannot proceed it. If it is more than 4 inputs, probably too much. We don't need to worry about these things, right? But we have to have at least 4. You can either restrict it exactly 4 or is greater than 3. Both are correct. Like if it is more than 4, we're ignoring those things. But it should be at least 4. If it is less than 4, then probably we have an error. So we need to handle those things first. So the second thing is like, first the number of input validation, then input validation for particular inputs. First one is the population, initial population. It should be within 0 to 1. 0 is not a valid number. 1 is not a valid number. How you can validate those things? Try except. Can you validate with try and except? How?
Try to convert it to the proper.
No, like I'm saying like how we're going to validate the range in between 0 to 1. Can we validate it with try and except? We cannot. So we need to use if statement like conditional, right? If it is greater than 0 or less than 1, then it's a valid one. Same thing for the population growth. If it is greater than 0 or less than 4. Third one is the number of iteration. It should be a positive number. Again, conditional. If it is greater than 0, 0 is not a positive number. Okay, what's the last one? Last one is the file name. You don't need to validate it, but you can validate whether it's a file name or not. That means there should be a dot and extension. That means the file name contains at least a dot sign. If there is no dot sign, that means it's not a file name. But before validating the range, you need to validate the inputs. The command line parameter returns a string type of value, just like our input function. That means if someone enters ONE instead of 0.1, it's an invalid one. So you need to validate whether it's the float number, right? Whenever you are converting that value to a float, you need to validate it. And how you can validate it? Try and accept, right? So using try and accept, you can validate whether it's a float or not. If it is not, throw some exception in the accept that it is not a valid number. It is not a float number. Does that make sense? Okay, I'll be discussing command line parameter at the end of this class, and next week we'll be discussing how you can write to a file. Okay, so we were discussing the list methods. How we can get all of the methods, given that we don't have any internet, we don't have our notebook, we're not memorizing the name of the methods. How do you know? The list of methods. What function you can use? dir, directory. Using the dir, you'll get all of the particular object methods. If it's the list inside the dir, you will get the list objects. Sorry, list methods. Okay. So for the list methods, so far what we have covered is like append, insert, then pop, remove, sort, sorted. What's the difference between those functions? Insert versus append. Anyone? Well, if you don't answer, then probably I'll call by your name. Kevin.
Append will add it to the end of the list and insert. I think just
While I'm going to insert.
where it's
That means I need to put the index there.
parameter
So,
or like
two parameters, the position and the value. What's the difference between pop and remove?
Takes the last one off, or just takes out an index, depending what you put in, and remove takes out value.
Yeah, by default, pop removes the last one unless you are providing the index. If you're giving the index, it will pop that item from that particular index, but the remove by value, not by index. And what's a sort versus sorted? Carter?
think sorts just like sorts by one value while sorted.
Anyone else?
Sort can change the numbers in the list into an order, and sorted keeps it kind of in the original form as it was before.
Yeah. The first difference is sort is a list method. Sorted is a built-in function, right? So whenever you're using dot sort over any list, it will change the original one. But sorted, it sorts and return a sorted one, not changing the original one. That's the main difference. Okay. Now, there is another method called extend. Well, for example, this is my list, an empty list. I'm going to append an item like 10. Then I'm going to append another item like 20. So if I'm going to print L, it will print 10 and 20, right? Now, can we add a list? Can we append a list? For example, I have a list of like 1, 2, 3. And now I have another list for like 5 and 6. In the list operation, I can concatenate two lists, right? L1 plus L2, which will create a new list. But if I would like to append 5 and 6 at the end of L1, then what can I do here? L2?
That make the fourth item of L1 just a list instead of adding the list?
Say again, what? The fourth one?
Won't that make the fourth item of L1 the entirety of L2 rather than adding two items to it?
Yeah. Yeah, actually, it is doing the same thing what you're telling. If I'm going to print it, now what do you think? Will it print 1, 2, 3, 5, 6? Well, definitely it will print 1, 2, 3, 5, 6, but is the fourth item is 5?
1, 2, 3, 5, 6.
So 5, 6 will be a whole item. Let me print it and see what it added. So it means 1, 2, 3, 5, 6. That means fourth item is the least. But our goal is to like, well, I'd have to add 5 and 6 at the fourth item and the fifth item. What can I do? I can do like this way. Well, this is my for loop for item in L2 and then L1 dot append item. Then if I print L1,
Here's still the original.
like this way. Means I'm using a for loop to iterate the next one and then get each item one at a time and add it to the previous list. The other way I can do that like a method called extend. I would like to extend the L1 with the L2. This will do the same thing. Now you can see the difference between L1 and like append and extend. If I have an extend, if I don't have the extend, it will print 1, 2, 3, then 5, 6 as one item. But in case of extend, it will be adding at the end of the previous list as an extension. So that's the difference between append and extend. Append is like appending an item, whatever it is. If it's the list, it will be a list within a list. But extend is like extending the previous one with the current item of this current list. This is really crucial. If you use append, probably you miss the 5 and 6. Not miss actually, you are getting 5 and 6 all together in one index. But now with the extend, you can easily get, well, 5 and 6 are two different indices. Okay. Any question about the append and extend? Okay. Now, I would like to discuss two important things here. One is the object value aliasing. What is an object and what's a value? As I told you in Python, everything is an object. String is an object, list is an object, other data structures are the objects as well. Integer is an object, float is an object, right? Now, if I'm writing a string like hello and B is hello, like two items, A and B. What do you think? Are they the same? Well, how do we know that whether they're same or not? Comparator operator, right? What's the comparator operator? Equal, right? So if I'm print and what it return? What does it return? True or false, right? If A equal B, it will print either true or false. It's true, they're equal, right? I also told you about an is operator. And I told you what's the difference between is and equal. Is checks with the, like equal only checks with the value. But is also checks with their type. object type. Like 2 and 2.0 are same value wise, but object wise they are not. One is integer, one is float. So if you're writing 2 is 2.0, it will return false. So what do you think? Are they the same object? A and B, they're two different things, right? In our memory location, it stores, like it allocates the memory for A, it allocates the memory for B. That means there are two objects, right? Let me see what it returns for the is object. It should return false. But in string, if the value are same, they are basically pointing one single object. They are actually one single object. So A and B are pointing that object. That means we have only one memory location for hello. A is pointing, B is pointing. So there is a function called like ID, which will give you the memory location of particular item. So if you print ID A, it will print the memory location of variable A and memory location of variable B. You can see those two values are same. That means when I'm writing hello, I'm pointing the hello to memory location. A and B are pointing that value. That means their memory locations are same. So one of the main reason is like string is immutable. That means you are not modifying anything. So when you're declaring hello for A, hello for B, that means you're not changing. If they're the same, why don't we just point the same location to multiple pointers, multiple variables? We can save some memory location here. Now, how about a list? How about a list? Well, they're same. So print A equal B will be true. How about this? A is B. Are they the same? Like a string? Not sure. Let me print. I'm printing their ID as well. They are not same. It's because the list is mutable, right? So that means if I'm going to change B, probably I'm not going to change A. So that's the main difference between string object and the list object, even if their values are same. Now, is there any way that we can just write one list and point two different variables to one list? Is it possible? Well, it is possible in this way. I'm creating a variable B and pointing to A. That means I'm not creating the whole B, but B is actually pointing A. Now, if I'm seeing that whether A is B, they are true. They are pointing the same memory location. That means if I'm going to change B2 is like 10, and then print A, eventually A is changed. It's because both A and B are pointing the same list, just referencing. This is called reference. And this is also called aliasing. We're using B as an alias of A. Now, it is important to know that whenever you're using a function and sending a list to there, in that function, if you are modifying something, eventually you're changing the list. Like I have a list like A1 to 3, and I'm calling a function like def change me, whatever the list. I'm just reading L1 and L1 is 10. And I'm calling change me A, print A. So what I'm doing here, I have created a list A. Then I'm passing that list. Probably I need to call this one here. There's my A. I'm calling this list while calling the change me function as a parameter. In the change me, I have a different argument L1, and I'm modifying L1. I'm not returning anything. What do you think? Will it change the original one? It will change. As because when we are calling a list as a parameter, it is basically we are referencing an object. Even if we're not returning, we're not doing anything, we are changing that particular reference. So L1 actually referencing A. There is no particular point for the L1. It means if you print the ID of L1 and ID of A, they are the same actually. ID of A and ID on L1 are the same. Or just down. ID of L1 and ID of A are the same. Yes.
So you're saying you don't have to return the value for that function because it just changes the original list, right?
You can return, it doesn't matter.
But you don't have to because.
You don't have to. Yeah, it's because it is referencing.
Uh-huh.
So what it does actually, for example, this is my memory location. I am creating a list like 1, 2, 3. Okay. Whatever the variable like A. In the memory location, it allocates the memory. So this is 1, this is 2, this is 3. And this location can be like 1001, 1002, 1003. There are the 3 locations for this particular variable A. Now, you are using a function called like change me and then L1. Is L1 actually pointing 1001? It is not allocating L1 here. It's just pointing the A variable. So keep in mind whenever you are using a list as a passing argument, make sure you're not changing that list inside the function so that it will change here as well. Okay. So this is also called like pass by reference. So whenever you're calling a function like in C, C++ or other things, there are like 2 types of function calling: pass by value, pass by reference. So previously what we have done, pass by value, but in the list, it is basically passed by reference. We're just passing the ID of this one to here. Whenever we're calling the function change me, here we're calling like in the ampersand sign or the what's the and sign is like the memory location of A. This is how it works, the backend. But don't worry about these things right now. This is the advanced things. We're actually passing a list as a reference. And this is also called aliasing. Any question? No? Okay, that's what you have mentioned here. They're like 2 variables, A banana, B banana, but they are actually pointing the same value for a list, for a string. But in case of a list, there are 2 different things. When I'm defining A and B, both the value are same, but they are two different sector in a memory location. But we can make it together. Excuse me. We can make it together by aliasing. In the aliasing, we are just write B equal A. Actually, B is pointing the memory location of A. So A and B are pointing the same value. So if you're changing B, it will eventually change A. And this is the list argument that I have told. If you are passing a list to the as an argument, it will eventually change, whether we return or not. This is how it works. So the letters and list are actually pointing the same list in the memory location. So when you're changing the list using the LST, it will eventually change the letters, even if we are just using a function parameter. Any question? Okay. I already discussed the sorted list and the list sort, and then append and extend as well. So here is a short table of different types of methods and their parameters and description. Append, it needs one parameter as an item, and it adds at the end of the list. Insert, it takes two parameters, position and item. It adds at a given position. Pop, by default none. It returns the last one. If you're providing position, it will return that particular index value. Sort, you don't need to put anything there. It will sort the list. That means you are modifying the original one, but the sorted actually not modifying the original one. It returns the sorted one. Same thing for the reverse. Reverse, modify the original list. Index, return the index of particular item. But if there are like multiple items, how do you do that? If you'd like to find an item, find the index of an item, and given that the item is multiple times in a list. So the first time it will give you the first item index. Then how you can go to the next index, next item index? Well, the second parameter or the first parameter of the index function is like the starting from here. I would like to look for this item and starting from here. By default, it starts from 0. And the good thing about the index function is you can limit the indexing, like starting and ending. Like in between this range, you are searching particular things. Okay, list comprehension. I told you about the function comprehension, calling a function within a function. List comprehension is like we are writing a list in a concise way. And typically we call these things like Pythonic way. For example, I would like to create a list from a given list, which is like a square of another list. Like I have a list of 1 to 3. I would like to create another list with a squared item, like 1 for 1, 2 for 4, 3 for 9. How we can do that? Well, the easier way is like this way. I have a list like 1 to 3. And then I need to create a list, which is basically squared of these things. So I'm creating a list like squared list and empty one, and then loop it for item in A, and then square it actually A multiply A. Sorry, item multiply item, which is like a squared of particular item, and then I need to append it to the squared list. Right? So this is like a normal way. So since you are learning Python, you need to know some Pythonic way. But this is like some advanced things, but at least you need to know something. So what is the syntax of writing a list comprehension? Square bracket, that means you're creating a list. Expression for item in sequence if condition, if there is some conditions. So right now we don't have any condition. We're creating a list. What is our expression? Squared, right? Our item is like squared. like expression is squared. Then for what is the item? Item. Yeah, A is the list actually. Actually sequence. In sequence is A. We don't have any if condition here. That's it in one single line. Instead of writing all of those 3 lines, we can just write 1 line. List comprehension. Sometimes we write, well, I would like to square only if the items are odd or even, for example. So what I can do here, we can write, well, if the item, how do you know it's odd and even? Modulo 2 is equals 0 is an number. An even number, right? So if we like to write this way, we can write, well, if the item modulo 2 equals 0. This is the list comprehension. Okay. Any question about the list comprehension? No? Okay, so last thing about the list is not list, LIST list, is the nested list. You already have learned nested conditionals, nested loops. Nested conditionals like a condition within a condition. Nested loop is a loop within another loop. Same thing for the nested list, a list within a list. That's what we have written before. We have like 1, 2, 3. Our initial list, and then we're going to add another list like 5, 6. If I'm writing A append, A append B, it will create 1, 2, 3, and for the last item is the 5, 6, a list another. So this is basically a list within a list. Okay. If we don't use the extend, then we have a list within a list. Now the question is, how can we access 5 and 6? If you write A 0, 1, 2, 3, right? A3 is, what is A3? A3 is like 5, 6, 2 items. A3 is the list, right? Now, if I'm going to access 6, the second item of that particular list, so this will return a list. If I'm going to access the second item of that list, this is how we can do. Like 2 square brackets, one for the initial indices and second one for the deeper one for that particular list. So it will return 6. Now we may have like list within a list within a list. Like instead of 5, 6, there might be other things like 100, 200. Then the A3 one will return 100, 200. Again, if we'd like to access only 200, it will be another state. This is called 3-dimensional list, but we're not worrying about 3-dimensional here. We're actually working with 2-dimensional. Okay. Now, why do we need to use a nested list? Well, a list is a sequence of number, right? Now, what if we have something like a tabular form? A tabular form like I have a table with the ID of the students, the name, and the grade. So for first one, maybe the ID is like 1001, name is like John, grade is like A, for example, or maybe a numeric value like 94. Another one is like 1006, maybe Doe, grade is like 91. Third one maybe like 1107, whatever. Dave, maybe 87. So these are like three information here. Now, if you'd like to process this table, how do you do that? Can you use a list here? Well, a list is a collection of data. There are a lot of data. This is a two-dimensional data, right? This is one-dimensional data, like one student data. If there are like multiple student data, it's like two-dimensional data. It's like X value and Y value, right? Now I can easily write a list of like for one student, 1001, John, and then 94. This is my first student data. The second student data can be like 1006, Joe, and 91. And the third student data can be 1107, Dave, and 87. These are the three student data. But there are like three different lists. Now, if I can create a top level list, like students, the first item can be like the data for John. Second information, the data for Doe. The third item can be the data for Dave, right? Now, instead of John, if I put that value 1001, John, then 94, then another Dave, another Joe. So this is a list within a list. So I have my initial list students, and each item is a list. Does that make sense? So for one particular student, I am creating a one-dimensional list. Now, if like multiple students, I can add all of those lists inside another list. So this is basically called a list within a list or nested list. So let me write it here. I'm just writing. This is very low. So for example, I have a data of, I think there are some examples here. Yeah, like this one. So ID, name, and score. If I'm going to write a list from this table, how I can write a list? So for example, for the first one, I have like 101, then Alice, then 88. For the second one, 102, then Bob should be string. And data is 92. For the third one, 103, then Carol, then 85. I have like three lists here. One for Alice, one for Bob, and another for Carol. Three lists, right? Yes.
It's an impact, but Carol also has 102 for the ID.
Who's that? Carol?
Carol's ID is 103, not 102.
Oh, okay. I have all the students' information, but if there are like 1,000 students, then probably I have like 1,000 lists. This is not a practical things. If I have like 10 classes per year, if I'm working like 20 years here, oh my God, it will be tons of data. So what I can do, I can create one list for one particular class. So this is my 1400 class. My 1400 class has this student, Alice, Bob, and Carol. Right? Now, if I'm going to expand it, instead of Alice, I can just put those information here. Same for Bob. You can write it here. Same for Carol. So this is basically a list within a list. So here's my previous list. Now I have another list in that list. Now, if I have like multiple score of Alice, it could be different one, like list within a list within a list. There will be like 3 lists here. Right? Don't worry about the 3-dimensional things. Just focus on 2-dimensional. Now, if I'm using CS1400, like accessing a list item, if it is 0, it will return a list. Information of Alice, right? If I'd like to know what's the name of that particular item or particular, a particular list, well, in that particular list, Alice is on index 1. So if I'm writing 0, 1, then it will print the Alice. Well, if I'm going to access through the loop, so for students in CS1400, right, where each student will print, actually each student will print a list, right? A list. Now, if I need to know what's the name of that particular student, well, I need to iterate that student because student is the list, right? We need to iterate that list. So again, item in student. Then if I print item, it will print 1 at a time. That's the list within a list and loop within a loop. Like whenever you are accessing a nested list, if it is 2-dimensional list, you need to write 2 for loops or 2 while loops, or maybe combination of for and while. If it is a 3-dimensional list, you need to write 3 nested loops. So consider these things row and column. So row wise and column wise. So all of the list items are stored in a row wise. This is the first row. This is the second row. This is the third row. So what I can do, we can just say, well, for rows in CS1400, for each row, I have the columns. Now, if I print the CS1400 row and column, so I'm using index, like I'm just looping through by its index. That's why I'm writing a range function and the length. So in this one, it will give me the rows, how many items are in the list. And for each row, I'm going to iterate each column, like index within an index. Now, if I print row within a column, it will print 1 at a time. What's the problem? Okay, so what is the value of row? So whenever you have a problem, just print it. What is the value of row? Integer, right? It is the index basically, 0, 1, 2. Now, if I'm going to use 0, 1, 2 as a range, first 0, second 1, third 2, it will not work. So how do I do that? What I can do, I can just, I need to go through the first items. Like in the first item, how many items? 3 items, right? So instead of row, what I can do, CS1400, 0th position, and how many items are there? That many columns. Given that we have the same number of columns. So for the first item, I have like 3 columns. This is how we can determine the column. It will print row by column, row wise and column wise. Okay. Now the important question is like, can you convert this for loop to a while loop? I saw most of your submissions, like you haven't converted a for loop to while loop. Instead, you just write while true to get the input. But there are like 2 functions, encoding and decoding for your last project. So I was expecting like for encoding, you're using for loop, for decoding, you're using while loop. To know like, you know how to convert a for loop to while loop. Instead, you have used like while true at the main function. Yeah, I gave you the full point. It's because you satisfied the rubric, but actually I was expecting this, like, can you convert a for loop to while loop? Now, can you convert this to a while loop? Well, probably that's the reason that's why you are unable to convert a for loop to while loop. So probably you have written this. Can you convert to a while loop?
Files, CS 1400. Nope.
While CS1400, nope.
No, sorry.
That's in the right syntax.
Okay.
Isn't none, but nope. Well, the important thing is like in this for loop, we are accessing without indexing. But whenever you are working with while loop, you have to use the indexing. So the first thing is like you need to convert this for loop to indexing for loop, right? How do you do that? Well, instead of item, it should be an index. And instead of the full item, you need to use the range function and the length. And now for the item, you need to call this way. Right? This is like for loop with indexing. Now it makes more sense to convert these things to a while loop, right? Index start from 0, it will go until the end of the list using the length function, and each time you will call one item at a time. Make sense? Any question about the nested list? Well, we'll be working with the nested list in the next class as well, whenever we're writing and reading from a file. Like if we have a CSV file with those tables, we need to read it from the file and maybe we need to write to the file. And we'll be discussing those things later in the next class. So the one last thing we have here is like command line parameter. What is a command line parameter? So previously what you have done, we are using input function to get the input. But now we'll be using a terminal value. We need to get the input from the terminal. So how we can do that? We can just use 2 different approaches. One is like system.argv, argument variable argv, or argument parser, argparse. There are 2 different libraries. Well, whenever you are using sys.argv, you need to import the import sys. Whenever you're using argparse, you need to import the argparse. Starting with the system.argv. System.argv returns a list of all command line arguments, including the script name. What's the script name? The first one. So the very first one is the program name, like Python 3 or whatever the version of Python you're using. Then the second argument, like after the space, the second argument is the script name. And the third onwards are another parameters. So whenever you're writing system.argv, the very first one is the script name. So arguments, since system.argv returns a list, the first one, you can access the list by its index. The first one is the script, and next onward are the parameter. So if I'm going through an example like this way, import sys, and I'm printing the script name and number of other. So since it's a list, you can use the len function to know what's the length of the system.argv. And I'm using this one, Python 3 example.py, given that the file name is example.py. There are like 3 arguments, 1, 2, 3. Then we'll have this information. Script name is example.py, number of arguments are 4. But we put here like 3, but this one also be included. That means for your project, we have like 4 inputs, but arguments length should be 5. First one is the script name. So here's some examples how you can validate. So for example, this one, I have like input file, a threshold, and output file. So I'm just calling the file. I'm just calling the script by this way, like Python 3 example.py, then 3 other arguments, input file, threshold, and output file. And this is how we can validate. Like we have like 3 inputs, but system.argv should be 4, including the script name. So if it is not 4, it is an error, or you need to throw some exception to the user. Then whenever we have input, for input and output, we don't need to convert anything since they're string. But for the second one, it's a threshold, we need to convert it. That's why I try and accept. This is how we can validate the inputs through the command line. For the debugging purposes, sometimes we need to know how many parameters are going to be passed. So we can just print system.argv with some messages so that we'll see that how many parameters are going to be passed. So now the limitation of the system.argvs are no automatic help messages, manual error handling, and the argument order matters here, and poor readability for the large programs. That means you don't have the type hint. Okay, this is the type hint, Cooper. Okay. So for the type hint, we can use the argparse. Argparse, for the argparse, you need to import the argparse, but you need to remember some syntax here. So for the argparse, starting with the argument parser function, you can use some description like a help thing. And then whenever you're adding a parameter, just use here. This is my variable parser, parser.add argument. This is my argument name, like a variable name. Then some type hint help. And since it is a string, we don't need to specify it. But if it is a float, we can verify it here like type float. We don't need to validate later on because it will validate automatically here. If it is not a float number, it will throw an error. But for your system.argv, you need to validate it manually. If it is not, like try and accept. Make sense? Any question about the command line parameter? You need to read it basically. But again, for the project, you need to use the command line parameter. If you have any question about the command line parameter, we can discuss those things in the next class. But you need to read it first. You could either use, system.argv or argparse. For system.argv, you need to validate those things manually. But for the argparse, you don't need to, as because it will create, it will validate those things by the type options. And for the type hint, you can use some help. This this is the keyword, this is the variable, I'm sorry, this is the function argument. So function name is add argument and the argument name is help. In that argument, you are passing the type hint. So whenever there's an error, it will show like input file name is missing, input file is required, input file threshold value should be a float, something like that. Okay? Any question? Oh, so you need to use this command line parameter for the project. Is that?
Sorry.